to explain something about the convex mirror. First of all, we have to learn the specific rays for a convex mirror, like we learned it for the concave mirror, and then I will explain the image formation, how the image is created for in the convex mirror. Image in convex mirror I will explain at the second part of this video. First of all, we have to know the specific rays of the convex mirror. In the first case, we had three cases. Let's put this one away. First, second, and third, fourth one. 4 rules, we can say, or 4 specific rays. We have it for the concave mirror, for a concave and convex mirror. First one, if you remember, we said when you send the light straight to the concave, straight to the mirror, that is the front side of the mirror, that's the back side of the mirror, and you know it's curved into the back side. That's why we have the focal point in focal length, focal point in this side, and the center in this side also. When you send the light straight, which is parallel with optical axis, when you send it, it's going to hit the mirror and reflect it away from the mirror. But if I draw an imaginary lines for this ray, for the refracted ray, I will see that it's going through the focal point. So for a convex mirror, always we should have an imaginary line for the refracted ray. Guys, for the second rule, we have the light is coming, and if you look at the direction of the light, it's to the focal point. We said when you send the light to the focal point, it must hit the surface of the mirror and reflect it back straight, guys. Reflect it back straight. As you see, it's straight. So if I draw an imaginary line for the reflected ray, it will be like this. That is an imaginary line for the reflected ray. And the third one, we said if you send the light through the center, it must be coming back through the center. Look, if I send the light through the center, look, it's going to the center. That's why I know it's to the center. So it's going to hit the mirror and reflect it back the same way, because this angle is equal to 90. That's why it must be comes back with the same direction. And the fourth one, we said if you send the light through pole, it must be reflected back like plane mirror, and that's the refracted ray. It's incoming ray, that is the refracted ray. So if I draw the imaginary line for the refracted ray, it will be into this direction. So I will just elongate this line. I can say elongate or draw an imaginary line for this point. I will repeat again. First one, we will send the light straight, and then it's going to reflect it back. When I draw the imaginary line or elongate the refracted ray, I will see it's going through the focal point, as you see. Second one, if I send the light through the focal, look, it's going through the focal, and it's going to reflect back through at the surface of the mirror. And if I draw an imaginary line or elongate the refracted ray, I will see the straight line. For the center, if I send it through the center, it must be reflect back from the center. And for the last one, which is pole, if I send it through the pole, it must be reflected back like a plane mirror. The angles must be equal to each other. If this one is equal to 25, this one must be equal to 25. So the imaginary line for the refracted ray will be into this direction, because we need those imaginary lines, guys. We need this one. We need this imaginary line, this one also, and the other one, and the first one also. That is the specific rays for the convex mirror. It looks like the same for the concave mirror actually. Okay, let's just keep this one into this side, and we can have the image formation for the convex mirror. Actually, we have one case. You can see we have one case. It is not like the concave mirror. For the concave mirror, if you remember, we had 6 cases. In the 6 cases we can have the image, but for this convex mirror we will have two cases. First one, when the object is at infinity. If the object is at infinity, will we be able to see any image? No, we won't be any image. We won't be seeing any image because it will be so small. So when the object is at infinity, we can just draw some lines which is coming straight. Look, that is the lines which is coming at infinity, like a light from the sun. It is coming straight to the mirror, and it must reflect back away to the mirror, guys. Look, if I draw this one, it must be reflecting back from the surface of the mirror. That's it. It goes away. And if I be able to draw an imaginary line, I will see it goes through the focal point, guys. For this one also, I will be able to see the light is going through the focal point. The imaginary line is going through the focal point. This is the refracted ray, and this is an imaginary line for the refracted ray. As you see, it's intersected at focal point. For this one also, the light is going away from the mirror, and the imaginary lines is going through the focal point. Look, this is the ray, goes away from the mirror, and that's the imaginary line which is passing through the focal point. And the last one also is like that, which is the line is going away from the mirror, but imaginary line is going through the focal point. I draw 4 lines. You might draw 100 or 1,000 rays, all of them coming from the infinity. You will be able to see all of them are going to, imaginary lines are going to intersect at one point, which is, we call it focal point. That is the focal point. So that's why the image is at a focal point. So we can say no image for this one. No image. Why? Because it's so small, we won't be able to see these images. Okay. The last case, and it is general, this one. Let's just send this one away, and let's make this one bigger to be more clear. Okay, for this case, what do we have? We will put the the object anywhere we like, except the infinity, anywhere we like. If you choose this point, this one, anywhere you like, you will be able to see the image is between the focal and pole. It means it will be between these 2 points. Except the infinity, anywhere you want. Let's put an object near to this point. Let's put it over there. Let's just have this. That is the object. That is an object. Let's have this object. Let's have this object. That is an object. It's the head of the object. It could be a man, or it could be just an arrow. It could be any object, a pen, or any object it could be. Okay, that's an object. First rule, what we said when you send the light straight, let's change the color. When you send the light straight to the mirror, it must hit the surface of the mirror, and it must be reflected back away from the mirror, and the imaginary line must go through the focal point. Look, it goes away, but the imaginary line must go through the focal point, guys. The imaginary line must go through the focal point. As you see, it goes through the focal point. That is for the first one. For the second one, I will choose another color. I'll choose the red one. And what we said, we said if you could send the light through the focal, it must reflect it back straight, right? So that is the focal, that is the head of the object. If I draw a line, which is going through the focal and to the object, and it must be reflecting back straight, right? That is the refracted ray, and it must be straight. Look, that is the straight line. Let's change it to the blue to be more clear. That's it. But if I draw an imaginary line, or if I elongate this line, I will be able to see the intersection point, guys. Look, now I can see the intersection point is occurring between focal point and the pole. So that is going to be the head of the object. So if it is the head of the object, so that is going to be an object. That is going to be an object. Now I can compare. That is going to be an image, image, and that's going to be an object. Look, the object is bigger, the image is smaller, right? That's why smaller than the object. We wrote it is upright, the image is upright, right? The image is upright. And it's virtual. Why it is virtual? Because it is at the back side of the mirror, backside of the mirror. That's why we will say it's virtual, and it's coming from the combination of or intersection point of the imaginary lines, not the straight lines, and not the real lines, and it's between the focal and pole. Look, guys, if you could look at this image, anywhere that you like, it must be between this point and this one. Anywhere you like, you put it, and it must be between them, between the focal and pole, nowhere else. Now I will just make it a little bit bigger to be more clear. The first, what we did, first we send the ray straight, and it must be reflected back through the focal, and that is going to be the focal. It's a little bit bigger, and the imaginary line should pass through focal point. As you see, it goes through the focal point. And the second one, we said when you send the light through the focal, that's it, and it must be reflected back straight. It must be reflecting back straight, but the imaginary lines are going to intersect at the back side of the mirror. As you see, that is the intersection point of the imaginary lines, guys. I hope you understand the convex mirror.